Okay. Hello. We're doing laws of logarithms. As said before, like I think the trick to logarithms is like being able to go through exponential form and logarithmic form, and I think they're not too bad. Anyways, I'm gonna rip through this. Let's see. So number one, there's a 1a, 1b. Number one, we have log base 3 of x. Let me get a little heavier. Is equal to -4. It changes to exponential form, so I'll say 3 to the -4. 3 to the -4 is equal to x. 3 to the -4, well, 3 to the 4 is 81. 3 times 3 times 3 times 3. And the negative is going to reciprocate it, so we get 1 over 81 is equal to x as part A. Part B, just ripping through these problems as quickly as we can. Log base 5 of 25 is equal to x. We could, you know what? I'm gonna go exponential form. Let's see. 5 of the x is equal to 25, but 25 is really 5 squared, so therefore x is equal to 2. That's no big deal. I only hesitate because this is technically laws of logarithms. And so you could rewrite 5, let's say log base 5 as 5 squared is equal to x. And then this 2 will come back down. Remember that this is an exponent. So if an exponent's raised by an exponent, we multiply. So we'd say 2 log base 5 of 5 equals x. Move on. Next problem. All right, on to number 2. Natural log of x is equal to 9. You got to recall that natural log really means log base e of x equals 9. And then I'll go into exponential form, sure. So e to the 9 is equal to x, so that's our answer. There's a part B to this. See, I would consider doing this. Anyways, I would just use the law of logarithms. Here's 3 is equal to x. I'll do it both ways. So remember, natural log is log base e. So you get e to the x is equal to e to the 3. So x is equal to 3. That's no big deal. And then if you treat it like, laws of logarithms, we can bring down that 3. So we get 3 times log of e is equal to x. And this is just 1. And so x is equal to 3. Think of like log base 5 of 5. Like 5 raised to what power is 5? It's just 1. This will always be 1. All right, moving on. Getting through this as quickly as I can. Let's see, 3a. I got log base 9 of 1 over 81 is equal to x. How many of these with laws of logarithms? He says use definition. Not sure what that means. I'm going to use laws of logarithms. So I'm going to rewrite this as log of 9 raised to the -2 power. And then I can bring down the -2. So I get -2 log of 9 is equal to x. That's 1. So x is equal to -2. Again, you can go to exponential form, but whatever's. All right, so let's see. This is 3b. This says log of 2 of x is equal to 5. I think this one I will go to exponential form. I think it's easier. So you get 2 to the 5 is equal to x. 2 to the 5th is 32. X is equal to 32. Just, it's not bad. These aren't bad. Let's see, 4a. Let's see, log base x of 64 is equal to 3. Again, I'll say x to the 3rd is equal to 64. Okay, so now this one's tricky. Actually, it's not. We're solving for x, so we'll say x is equal to the cube root of 64. I don't know if Levinstein will take that answer, but what times what is 64 will give you 4. That's not bad. Part B, it says log of, it feels like the same question, but maybe not. Let's see, 125 is equal to 3 halves. Excuse me. Again, I'm going to write this as exponential form. X to the 3 halves is equal to 125. let's see. I'm going to get rid of the, so if you think about it, this can be written as 1/2 raised to the third power. And the reason we can do that is an exponent raised by an exponent. You just multiply those two exponents. And then I'm going to get rid of the 3. So I'm going to raise both sides, and this is going to look weird, but I'm going to raise both sides to the 1/3 power, which is equivalent to the cube root of 125. The 1/3 power and cube root are the same. If it was 1/4 power, it would be the 4th root. 1/5 power would be the 5th root. 1/2 power would be the square root. Anyways, continuing here, you get x to the 1/2 is equal to the cube root of 125 is 5. And then I'm going to square both sides so that I can get rid of this 1/2 power. And so I get x is equal to 25. I don't know if that was the best way to do it, but it was a way. It was a way. Try to think of a better way. Oh, well, moving on. I'm moving on. On to 5. Okay, so again, the laws of logarithms and the laws of exponents, I mean, they're basically the same. So if you had like b to the x times b to the y, you get b to the x plus y. You know, when you have the same bases and we're multiplying, we add the exponents. It's no big deal. Let's keep the base, add the exponents. Like, you kind of do the same thing with laws of logarithms, but it's like a little bit backwards because we're talking about the inverse. So if we say log base b of x plus log base b of y, then we get log of b of x times y. Hold on. What's up? Hold on. Man, I don't know where I was at on this, but as stated here, let me see if I can move this up. I mean, it's basically the same. I know it's hard to say like, oh, they're exactly the same, but like, notice that you're adding, and then, you know, like you're multiplying these, and then you're like adding, and then you're like multiplying these. It's basically the same, written a different way. At some point, you should prove these in your classes so you have a better understanding, depending on how good your teacher is. All right. Let's continue here. Oh, this is number 5. I actually didn't do 5 yet. The logarithm of a product of two numbers is the same as the sum of the logarithm of these numbers. Okay, yes. So basically backwards, I guess. Log base b of x times y is equal to log base b of x plus log base b of y. I'm just going to throw a random example in there. So I do like log 5 of 125. Oops. I'll do, 5 times 25. Okay, so if you look at 5 times 25, that's 125. 5 to the third power is 125. And so log base 5 of 125 is just 3. But if you worked on this property here, you can rewrite this as a sum, as long as provided the bases are the same. Log base 5 of 25. This turns into 1. This turns into 2. So you get 1 plus 2, which is just 3. Yeah. You know, it all works out. Math's supposed to work out. Always. Always. There's no like, what? How does that work out? No, it always works out. Always works out. All right. Number 6. It says the logarithm of a quotient of two numbers is the same as the difference of logarithms. Oh, wait. Was there a problem to do? Oh, shoots. I was supposed to do problem. Okay. There's an actual problem to do on 5. Let's see, log base 5 of 25 times 125. See, and the whole point of this like law is like, I don't want to multiply these two together. So I can rewrite as a sum of logs, 25 plus log base 5 of 125. And then each one of these is very easy to do. So that's simply 3 or 2. And this is 3. And so I get an answer of 5. Yeah. I guess they just wanted this part, but whatever, it doesn't matter. All right, number 6. All right, 6. Now we're talking about when we're talking about a quotient, then we take the difference of the logs. So log base 5 of 25 over 125 is log base 5 of 25 minus log base 5 of 125. And I guess they just want this value. That's not hard, but I'm just going to continue. This is really easy to calculate because this becomes 2, and this becomes 3, which is -1. I know someone's going to like, oh, it's not reduced to 1/5, and that's just -1. Yeah, but it's just another way of being able to do it. Like, it's nice to know different ways of doing the same problem, because in certain situations, one way is a lot easier than the other way. And that's really what we're trying to teach in math. And that's why, like, I'm not really big on, having kids learn the steps. It's really, you should learn the tools. And based on the tool, that's the direction you go in. All right. Let's see, 7. The logarithm of a number raised to a power is the same as the power times the logarithm of the number. Okay, no big deal. I don't think. Oh, yeah. So log base 5 of 25 to the 8th is equivalent to 8 times log base 5 of 25. That's pretty easy. And it's really easy to show. Like, it's really easy to prove, because this would be log base 5 of 25 times 25 times 25 times 25. And there'd be 8 of these. And then this would turn into log base 5 of 25 plus log base 5 of 25 using the first row of logarithms. And there would be 8 of these. And repeated addition is multiplication, so you just get 8 times log base 5 of 25. It's again, it's supposed to like make sense. Supposed to. All right. Number 8 says we can expand. Okay, so we want to expand this. So I say log of x to the 6 y over z. All right, so I'm going to first use think of this as like a grouping symbol. So you have the top and the bottom. So I'm going to write that as a difference of 2 logs. So I get x to the 6 times y minus log of z. And then I'm going to write this as a sum. Log of x to the 6 plus log of y minus log of z. And then for whatever reason, when we talk about expanding logs, they always want the coefficients in front when you can. So this is 6 log of x plus log of y minus log of z is the full expansion. I know like this and this are the same. Like, I don't know why they consider that a full expansion. It's like the same to me. All right, on to the next one. We can combine 6 log x plus log y minus log z to get, okay, so now we can't combine these. We can't like use our law of logarithms. The coefficient does have to be 1. So now you have to bring it up. So I guess the other part is they want you to practice bringing that up. Plus log of y minus log of z. Now you can write this as a single log. So we say log of x to the 6 times y minus log of z. And so this is log of x to the 6 times y over z as the answer. No big deal. No big deal. No big deal. No big deal. Okay. Oh, this is a good one. This is a good one. So if I had like log base 10 of g plus d, and they're asking, is this the same as log base 10 of g plus log base 10 of d? This is not the rule. This has to be a product. And that's a really, really common mistake. But like, it's easy to show. Like, it's really, really easy to show. Suppose I had like, I don't know, 10 plus 100. All right, so then you get log base 110. Now I can't calculate that because 10 doesn't divide. 10 to some power isn't 110. Like, I mean, you could approximate. It's gonna be like 2 point something, but I can't calculate it. And then if I were to do this side, I'd get like log of 10 plus log of log of 100. And log of 10 is 1, and log of 100 is 2, so this answer is 3. But these are definitely not the same. This is equivalent to log base 10 of 1,000. But yeah, that rule's garbage. False. However, this rule is good. Log of g times d is equal to log of g plus log of d. Yes, that's good. Really good. That's our law. All right, moving on here. Let's see, log of 500 plus log of 200. Okay, so this is log base 10, and no matter how hard I try, 10 to the sum power is not going to be 500, and 10 to the sum power is not going to be 200, so I'm stuck. So I'm going to use one of my tools, one of my laws of logarithms. I only have 3 of them, specifically the addition one. I can write this as a single log, provided I multiply the things on the inside. And I'm going to multiply it like this way, and hopefully you understand. I'm going to say 5 times 2 times 100 times 100. Like I basically decompose the number. I think it's better that way. Like this is 5 times 100, and that's 2 times 100. So 5 times 100 and 2 times 100. I just, again, I don't want to use calculators. Like if you're really doing the math, like this math was invented way before any calculator, way before any calculator. All this math can be done without a calculator, easily. Anyways, I would do this 5 times 2 is 10. I would do this as 10 squared, and I would do this as 10 squared. When we're multiplying, we keep the base and we add the exponent, so this would be 10 to the 5th power. Oh my god. And I'm going to bring down the 5 here, and so this is 5 log base 10 of 10. And so log base 10 of 10 is just 1, so this answer is just 5. I'm getting yelled at. I don't want to be yelled at. I get yelled at school enough. Is that a negative? I think that's a negative. I don't know. All right, so negative 1/4 log base 2 of 16. Now there's 2 ways you can do this, and maybe I'll do them both, but one way I was thinking that is doable, I would do log base 2 of 2 to the 4th power, and then I'd bring down this 4th power down, so I get 4 times negative 1/4 log base 2 of 2, and as we said many times, log base 2 of 2 is just 1. 4 times negative 1/4 is just negative 1, as one way of doing it. Now doing it the other way, I'm going to move this up because I can do that. I could either move them down or move them up. So it'll be log base 2 of 16 raised to the negative 1/4 power. And this is log base 2. I think I might do the same thing. I'm going to write this as 2 to the 4th power. So 2 to the 4th power, raised to the negative 1/4 power. And then when it's exponents raised by exponent, you multiply them. And so you get log base 2 of 2 to the negative 1 power. And then I can bring that negative 1 power down. Negative 1 log base 2 of 2 simply turns into 1. And so we get an answer of negative 1. I mean, either one, you should be comfortable with both ways. It's not bad. It's not bad. Moving on. I feel like I'm going to get yelled at. Wait, never mind. Okay, 13, I think. 13 log base 3 of 15 minus log base 3 of 35 plus log base 3 of 567. What? Let's see, 11. I guess 3 goes into that. I have no idea what to do. All right, let's figure it out. All right, log base, at least attempt to figure it out. I can write the first 2 as a single log, so I can say log base 3 of 15 divided by 35. Okay, that looks good. Plus log base 3 of 567. Okay, is that right? 567, sure. All right, I can reduce this. Again, I wrote this as a single log. I can reduce that by 5. Sure. I'm a little confused with this problem. Okay. And then plus log base 3 of 567. excuse me, I'm going to write this as a single log. Log base 3 of 3/7 times 567. If I had to guess, this would be so nice if 7 goes into 557, and I think it does. I think it goes 81 times. Let's see, 7 into 567. 7 goes into 56 8 times. This is 56. That's 0. Bring down the 7. So this is 81 times. Oh, that's perfect. That's perfect. That's perfect. So log base 3 of 3 to the 7s times 81. But I know, oops, these 7s are going to cancel out. I get log base 3 of 3 times 81. But I know, not everyone knows. 3 times 3 times 3 times 3 is 81. So I get 3 to the 4th is 81. This is really log base 3 of 3 to the 5th. I can bring down the 5. This turns into 5. Log base 3 of 3. And so therefore this answer is 5. Look at that, no calculator. So you don't need a calculator in math. Calculators are for science. That's why they're scientific calculators. Scientific calculators. Don't need it. Okay, maybe on this next one you need it. Yeah, I spoke too early, I think. All right. Log base 2 of 8 to the 89th power. That doesn't sound good. Now, I could bring down the 89, so I say 89 log base 2 of 8. But I know 8 is 2 to the 3rd power, and I can bring down the 3. So this is going to be 89 times 3 times log base 2 of 2, but log base 2 of 2 is just 1. All right, so then I got to figure out 3 times 89. 89 times 3 is, I don't know, I can't think right now. I don't know. Why is this not working out? 267? 267. 3 times 4 is 24. Plus 2. 267. Okay. Moving along. 15. Only a couple more, I think. Here's 15. Natural log of the square root of a times b. Okay, so this is equivalent to the natural log of a times b raised to the 1/2 power. You can bring down the 1/2 power. This is 1/2. I don't know what we're doing here. Use logarithms to expand. Okay, so 1/2 ln of a times b. We can expand that one more step further, but be careful because that 1/2 is going to be in both expressions. I hope that makes sense. You gotta have those parentheses there. It's wrong if you don't have those parentheses. Gotta. It's 1/2 times this whole thing, and that whole thing can be rewritten as ln of a plus ln of b. All right, I think my last problem is good because the kids and family are up and they're gonna start yelling at me. Oops. So here's a. So I got log base a of x to the 8th over yz to the 9th. Okay, perfect. I'm gonna separate this, and you just gotta like use parentheses appropriately. So this is log of y times z to the 9th. I swear that's a 9. I can bring down this a, like for whatever reason, expanded form, we can't have any exponents. So we say a log of a of x minus, and now you have to be careful here because this minus is being distributed to this entire log, and we're splitting up this log into 2 logs. So it will be log base a of y plus 9 times log base a of z. I skipped a little step there. This is going to break up into a sum because of that, and then I brought down the 9, but I believe I'm done, and I gotta finish because everyone's up right now. A lot of yelling's going to start happening. All right, perfect. Thank you.